All right. Good morning, everyone, and welcome to the Offshore Wind Academy podcast. I am Serene, and today we're discussing one of the most critical of the floating offshore wind turbine, which is the mooring system. It is keeps these massive stable in some of the harshest environments on Earth. Joining me is Danny Golden, the co-founder of Dublin Offshore, and we will talk about a technology designed to rethink how mooring systems handle extreme loads. It's called the Load Reduction Device, or LRD. Thank you, Danny, for joining us today.
Pleasure. Great to be chatting with you, Serene. Looking forward to our chat.
Awesome. And I have a lot of questions, but let's start with the fundamentals. What specific problem in mooring design were you thinking or were you trying to solve?
It's a pretty fundamental question. Basically, over the next 20 years, floating wind is going to spend something like 100 billion on mooring systems, and that is going to be procuring components that currently the supply chain doesn't exist for them. That they're either bigger than the oil and gas equivalent, or they're just the scale is so much greater than oil and gas because of the number of platforms in floating wind. So we're approaching this as a design problem as opposed to a supply chain problem. And we have come up with technology that allows those mooring systems to be redesigned in a way that, number one, significantly reduces that cost, and number two, moves it away from those supply chain bottlenecks that otherwise the industry is going to hit. Effectively, there's a lot of floating wind in development, and over the next few years, they're kind of planned to be built at the same time. And because it's a global supply chain, all the factories, all the vessels to install them, every piece along that delivery path just doesn't exist at the scale that's needed. So we're able, through our technology, to redesign those mooring systems to be aligned with what is actually achievable, and to, that 100 billion that would have to be spent. We're talking about cutting capex of the moorings by something around 50%. So that 100 billion,
we're going to talk about the capex.
Reduced. Sure.
Yeah, we're going to talk about the capex and costs in a minute, but just in simple terms, how does the LRD work, and what makes it different from traditional, let's say, compliance solutions like nylon tails or other kind of rope sections? So if you can explain to us exactly what this technology or what this device achieve.
Yeah, for sure. So it's a technology that's installed in line within a mooring line. It's very simple. It's basically a steel tube that at one end it's ballast and at the other end it's buoyancy, and we're connecting the mooring line into it at specific points, and that basically allows us to leverage gravity in a way that other systems don't. And so the clever bit is in how we engineer the component and make the most of that really efficient leveraging of buoyancy and ballast. It's almost like if you took a clump weight and a buoyancy unit and mashed them together, but you did it in an extremely clever, low risk single component. And then that allows you to remove other components.
I saw one of the videos and I found it super interesting. Could you share that video that shows how this device works?
Yeah, for sure. So if you can see my screen share there, what you're looking at on the right. If you can see my screen share there, what you're looking at on the right is the LRD integrated within a mooring line. And you have a top line that's coming from the platform that's connected at the lower hinge of the LRD. And so that's like it's lifting up the ballast section at the bottom. And then the bottom line, which is going down to the anchor, is actually connected to the top arm of the LRD. So it's bringing down the buoyancy section. And so we engineer that system with very specific buoyancy and ballast and very specific positions of those hinges on the body to deliver a bespoke stiffness response. You can kind of think of it like a spring response but we're using gravity.
Mm-hmm.
And that means that we can integrate a bespoke compliance within the system that allows the system to be redesigned. So you can have a much softer response in ways that allow you to bring down a peak load. And then that peak load is typically what's design driving, and you're paying for big chain and big anchors that are sized for a 1 in 50 year storm. And then we were able to, analyze and predict the loads related to that 50-year storm, but optimize the system, lean engineer the system back down so that you don't see those loads. You integrate the LRD. It gives you that nice soft response just when it's needed in those design driving cases. And you end up with a system that's, like I said, maybe 50% lower cost. But that's kind of the fundamental technology piece. We integrate a complementary or a beneficial response in the mooring, and that allows you to redesign it.
And is it installed? It looks like you install it in the inherently stable technology like semi-submersible or spar, right?
Yeah, I think the biggest chunk of the market is going to be those type of, like you say, inherently stable kind of slack moored systems. There are applications in TLPs, but it's kind of not our first preference, and it's not our first market. Certainly the barge, spar, and particularly the semi-sub markets will be kind of first movers for us, and that's where we're focused on. And it's it's within an excursion envelope where we can have a pretty significant impact in improving those systems.
It looks like you installed it in the first third of the mooring lines. Was it the snap loads or the extreme storm line cases, or something else that became the real constraint? Because my understanding from you explained it that we just needed when we have a extreme or severe storm event, right? But we still need it in every single turbine in the project.
Yeah, it depends on what's design driving in your project. Typically, it's the 50-year storm case, so 100-year storm case, depending on how you're designing for. If you see in the graph in the middle with the high peak, that's actually from a French Atlantic site we've been working on, where that high peak is related to their 50-year storm case. We could integrate an LRD. We could reduce that load by about 70%, reduce the dynamic load, and that's the 50-year case. But if you see the time series of load in your smaller waves, which are either side of that peak load, it's also a much smoother response. So all of your operational fatigue that would be accruing over the 25 or 30 years of the lifetime of the farm, that's also significantly reduced. So if you're a fatigue driven system, we can reduce fatigue. If you're a extreme case driven system, we can reduce that snatch load, like you say, that big peak load that's driving the sizing of the components. It's basically just smoothing out the signal, the tension signal, and taking out the peaks. And it's those peaks that are design driving.
And you just mentioned that you are applying this technology today, right? So you have the technology is already ready. It's TRL, I would say 7, 8.
Yeah, exactly. It's TRL 7.8. We've just finished full prototype certification with DNV. So that means that every aspect of this, from the design basis to the design, all the manufacturing, all the performance side of it, that's all fully certified with DNV. And because, like you can see on screen, it's just a simple steel tube. There's no real difference between this at 1 megawatt scale or 20 megawatt scale. It's just a slightly bigger tube. And so all of the certification and the kind of technology development is already there. And yeah, we'll be putting this offshore in the US, actually, which might be of interest for your American-based audience. Just in the process of shipping one out at the moment for a project on the East Coast into a floating wind system there this summer. So yeah, full steam ahead. It's very hard to predict where floating wind is going to go in the next few years, but we're both feet into it. Let's say we're getting ready on the basis that it's going to take off.
It looks like you are getting ready for that. And let's move to the cost and the capex, because you mentioned at the beginning that you're cutting or reducing the capex 50% with this technology, but you're basically adding another component to the supply chain, which is something might be concerning for investors or for developers. So let's talk from a cost perspective. So how are you truly reducing the total mooring line capex, or are you just shifting cost from steel to a technology. Can you explain how you are going to achieve the 50% of the cost reduction?
Yeah, absolutely. It's a great question, and it's it's back to your first question. It's what's the fundamental problem, and the cost is what we're that project system level cost is what we're working towards. So the cost reduction comes from system redesign. The best system you can put out today without an LRD will be something close to twice the cost of the best system you can put out with an LRD. So the LRD is it's only part of the puzzle. It's just a subcomponent, but it enables a mooring designer to make all sorts of cost-effective decisions in their design loop. So as you go through a design process, you'll be able to remove mooring lines, use smaller sections, smaller chain, smaller diameter chain, lower MBL rope. You can bring your anchors much closer to the platform because the LRD is delivering the compliance instead of the ground chain or instead of ropes that might be in the system. We would typically see a lot of opportunities for removing things like clump weights and buoyancy units and other components like that. So when you do that engineering exercise and you have an option A and an option B, the option that includes the LRD is always going to be the cheapest option, by a significant margin. But it comes after a couple of design iteration loops with a good mooring designer.
And this is
That's
very
where the cost
interesting because I found this to be interesting because developers today and many stakeholders are thinking of shared anchors or shared mooring lines as one of the cost reduction methods. So do you think this device, the LRD, is going to be um, deployed with the shared anchors, or are you still um, testing this?
They're very complementary. It's actually a paper we'll be presenting in Tokyo this summer on that topic of integrating LRDs with a shared anchor array configuration. Because an LRD can allow you to reduce the number of lines per platform, you then effectively multiply your savings because you can still use shared anchors between those platforms, but you've already, maybe reduced your number of anchors by about 30% using an LRD because you have fewer lines. And then you cut that again with having shared anchors. So the combined cost savings are very significant, and they're absolutely complementary approaches. The LRD is optimizing each mooring line, and then the shared anchors is allowing you to just be very efficient with your resources at a farm level.
Yeah, this is really a fascinating discussion because mooring systems have always or long been treated as a fixed constraints in floating wind.
Yeah.
But this technology or similar technologies like the R&D really challenge the assumption and open the door to, let's say, smarter load management. Our time is already over, and this is a really interesting conversation. But thank you again for sharing your insights, and thank you to our audience who joined us today. And if you are working in floating wind design or system integration or offshore structures, this is an area worth watching closely, especially with Danny's comments on coming to the United States. So this is something really interesting. Thank you again, Danny, and we look forward to see this device here in the United States.
Yeah, me too. Looking forward to getting over this year. Thanks so much for your time. Great to talk to you.
Right. Thank you.